Good day, seniors. This video lesson will be having combinations. Remember that combinations are arrangements without regard to order. The order is not important. Now let's have this problem. From a box containing 6 red balls, 8 blue balls, and 10 green balls, how many ways may 5 balls be selected such that 3 are red, 1 is blue, and 1 is green? So these 3 red balls, 1 blue, and 1 green will make up the 5 balls that we will select from this group 6, 8, and 10. Think of this as a series of 3 steps. The first step being selecting the 3 red balls. So if you are to select 3 red balls, you will select it from the 6. So you have 6C3 as the first step. The next step would be selecting the blue ball. Remember, you are to select 1 blue and there are 8, so that would be 8C1. Remember that you should multiply the successive steps, so based on the multiplication rule. The last would be, the third step would be, or the last step would be selecting the 1 green ball from the 10 green balls. It's simply 10C1 or 10 choose 1. So just multiply this 3 and you get, calculator, so that's 6C3 times 8C1 times 10C1, that will be 1,600. Okay, what if the question is this? You have, instead of asking the selection that should be 3 red, 1 blue, and 1 green, the problem says you are to, how many ways may 5 balls be selected such that exactly 3 of them are red. So if that's the case, the first step is to first choose the 3 red balls again. So that's 6, choose 3, choosing the 3 red from the 6 available red balls. Now we are to select 5 balls, so we need 2 more. But in this case, there's no mention whether what we should select is a blue, is colored blue or green. Therefore, the color here doesn't matter anymore, whether it's blue or green or both. So we're just combining 8 and 10. From these 18 balls, we select the 2 remaining balls. That's 18 choose 2. So basically the 2 step here. So 6C3 times 18C2, and let's get that value. So you have the answer here is 3060. Okay, about this variation of this the same problem. How many ways may 5 balls be selected such that at most 3 are red balls? So take note and be very careful of this word when you see this word at most. That means the maximum that you get should be maximum 3 red balls. So that only means that you get that 3 red balls are possible. Can also have 2 red. Remember, at most means maximum should be 3. So you can have 2. And then you can have 1 red, and you can have no red at all. Right, so here in 3 red, this is basically letter B, the choosing 3 red balls. So it's 6 choose 3 times 18C2, which is 3060. But you have exactly 2 red balls selected. That is 6C2. And remember that we need 3 more, so that's what we will choose from the 18 other balls, blue or green, combine them, so 18C3. So let's have the value later. 1 red would be 6 choose 1, and then 18C4 this time because we need 4 more, choosing from again the 18, and then no red would be 18C5. So remember, that doesn't mention whether you want the balls to be blue or green, so just combine them, 8 and 10, that's not red. So you have 6C2 times 18C3, that will be 16,320. Wait, so 6C2 times 18C3 is not 16,320, it is 12,240. Then 6C1 times 18C4 is 18,360, and then 18C5, that's the case wherein we have no red at all. We have 8,568. So now to answer the question, the letter C, how many ways when we select 5 balls if the ball selected contains at most 3 red balls, simply to add all these 3 cases up. So addition rule applied. So we have 8,568 plus 18,360 plus 12,240 plus 3,060, and that'll give you total. So just add this up. So the answer to letter C would be 36,108 ways. Okay, now let's have next example. How many straight lines can be drawn through 10 points, no 3 of which are collinear? This is the classic example wherein the condition here, take note of this, no 3 of which are collinear. So when you see this, that's the easiest that you can get. You know that to draw a line you need 2 points, and then you're given 10 points. So the answer here is basically 10C2, and that's it. So if you want, you can draw 10 points, no 3 of which are collinear, and then count the number of lines that you can draw, and you should get here 45. So there are 45 lines. But in this problem, we'll be varying the question a little bit. So you have this question instead. How many straight lines can be drawn through 10 points, 4 of which are collinear? So you have 4 collinear points, then the other 6 points are not, no 3 of which are collinear, so the same condition as before, but this time we have 4 points which lie on the same line. So let's at least have that. Let's at least draw that case. Okay, so have this at the point 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's have, in this problem we have 10 points, 4 of which are collinear, so meaning they lie on the same line. Let's have this line, blue line. Okay, those are the 4 points that are collinear, and these other 6 points, no 3 of which are collinear. So that's basically the problem. So how many ways can we draw? How many lines can we draw from these points? So let's just draw some, not all, but just some. This would be one line. 1, and let's count. We already have 2 lines drawn here. That's the second one. This would be the third. This would be the fourth. This would be 6th. This would be the 7th. This would be the 8th. Okay, let's fix that. Okay, let's move the other points so that we are not collinear with the others. So I've drawn 8 of the lines already. So you get the point. So we are counting how many lines can be drawn through this, with this condition that 4 are collinear. First, if we disregard this condition, 4 which are collinear, we simply go back to the original case wherein no 3 of which are collinear. We get 45. But you know that the number of lines we should get from this new condition will be less than this, because 4 of the lines will be 4 of the points are on the same line. So how do you answer this? So we should subtract something from 10C2. So to do that, let's see the case of the lines of these 4 points on the line. So remember that this should be counted only as 1. So these 4 points, if you think that it will make lines, so if these 4 points are not collinear with each other, they will create, or at least you can draw 4C2 lines through them. But remember that they are in the same line, so we should subtract this. So we are basically deleting the number of lines that can be drawn through 4 points, no 3 of which collinear, from the whole thing 10C2. So but remember that there's this line here should be counted only as 1. So therefore you should add 1. Okay, so you have 10C2 minus 4C2 plus 1. Now the reason why we added 1 is that since we deleted the lines that can be drawn through the 4 points, but deleted the line itself, so we should put it back. So it's plus 1. So the answer would be 10C2 minus 4C2 plus 1, and then that would be 40. So there are 40. The answer here would 40 lines. Now if you want to verify this, you can draw the points following the condition and you count the number of lines. Let's have another of the same type. Let's have this. Okay, so you have how many straight lines can be drawn through 10 points, 7 of which are collinear. So here, in this case, there are 7 points that lie in the same line among the 10 points. So this is basically easy to count. 1, 2, 3, 4, 5, 6, 7. Suppose these are your 7 points that lie on the line. So the other 3 must be in the other, not on this line. So we can basically count here. So you have here 1 coming from this point, 2, and then 3 coming from this, you have 4, and then 5, and then 6 here, 7 from here, 8, and then 9 from this point, 10, and 11, and 12 from this, 13, 14, and then 15 from this. We have 16 lines already, 17, and then 18 from this. We have 19, and then 20, and then 21. Remember, including this line also, you have 22, and then from this, this is the 23rd line. The other will be the 24th line. Then finally, this one. So you have all in all 25 lines. Now, let's see what we did earlier. We should subtract something from 10C2. There are 10 points, but there are 7 points which are collinear points. So let's subtract all the lines so we can be drawn from those 7 if they are not collinear. But remember, we are deleting all the lines we can get, and we know it should be counted as 1. So we add 1. So let's see. That will be 10C2 minus 7C2 plus 1. And of course, we verify that the answer is 25. That's it. So if you want, going back to the previous problem, I drew this because it's easier to make, but you can verify this problem, the problem before. I mean, the condition wherein you have 4 of which are collinear. So here 7 of which are collinear. It's easier. So I drew that. So anyway, good day.